Hello everyone, in this video we shall understand how we can use this direct online starter circuit to supply power to an induction motor. And for this purpose we will first look at its single line diagram and then examine each of its components to see how it works. This is the power circuit for the direct online starter. We have three main components, namely the main circuit breaker. This is also called the miniature circuit breaker, the main contactor that makes or breaks the contact between the source and the load, and we have here for our protection the thermal overload relay.
This part of the single line diagram is the control circuit for the direct online starter. Once the control circuit MCB is closed, current will flow from the single phase source through the normally closed contact of the thermal overload relay and will energize the auxiliary contactor coil D1. As soon as the coil energizes, the normally open contact of the auxiliary contactor closes and the circuit is now ready to start with the push of the on button. When we press the on button, current flows from the single phase source through the normally closed contact of the off button through the normally closed contact D1 and energizes the main contactor coil, which leads to the closing of the main contactor contacts and the motor starts to run. The normally open contact C1 is used here to prevent the circuit from powering off. Since it is a normally open contact, it holds the circuit once we let go of the on button by latching onto the source. Now to turn off the circuit, there is an off button. It is a normally closed contact which breaks the circuit once it is pressed. As the circuit breaks, the contact C1 can no longer latch onto the source and hence the flow of current is stopped, which de-energizes the contactor coil.
In this line segment of our control drawing, we can add contacts from our safety relays such as thermal overload relay, PTC thermistor relay to trip the circuit in case of failure. And additionally, from this segment we can also form interconnections with other motors. This is the terminal strip. It is used to label connections, which makes it easier for us to physically put together this circuit and helps to avoid making wrong connections and rectifying the circuit in case of an issue. This is the direct online starter circuit. It consists of three main components: the MCCB or circuit breaker, the contactor and thermal overload relay for overload protection of the equipment. A circuit breaker is an electrical safety device that is designed to protect an electrical circuit from damage caused by an overcurrent or short circuit. Its basic function is to interrupt current flow to protect the equipment and to prevent the risk of fires. The contactors are electrically operated switches that provide a safe and convenient means for connecting and interrupting branch circuits. These contactors are an economical means of starting and stopping motors and have the advantage of being controlled remotely. The contactor has three main normally open contacts and four lesser power rated contacts named auxiliary contacts used for the control circuit. Overload protection for an electric motor is necessary to prevent burnout and to ensure maximum operating life. Under any condition of overload, a motor draws excessive current that causes overheating. Since motor winding insulation degrades due to overheating, there are established limits on motor operating temperatures to protect the motor from overheating. Overload relays are employed on a motor control to limit the amount of current drawn. Please note that the overload relay does not provide short circuit protection. That is the function of overcurrent protective equipment like fuses and circuit breakers. The direct online circuit has been set up to test its operation, and for that a three-phase induction motor has been connected to it. This is a 1.5 kilowatt motor that consumes about 4 amperes at full load. Hence the thermal overload relay has been set to 4.5 amperes and the circuit is being supplied by three-phase power from an industrial socket. According to the single line diagram, closing the circuit breaker C6 allows the current to flow through and energize the auxiliary coil D1. And once D1 is energized, the normally open contact of D1 would close and now the motor can be started with the push of the on button. Now I will proceed to close the circuit breaker and press the on button on the panel for the motor to start.